Find the support reactions of the beam loaded as shown in figure. This is rectangular loading, this is triangular loading, this is inclined loading, this is point load, and this is couple of 2 kilonewton meter. Anti-clockwise couple of 2 kilonewton meter. And this is roller support and this is hinged support. We have to find out the reactions developed in these supports. This support and this support, reaction at B and reaction at E. Now, simplifying this 5 kilonewton force into horizontal and vertical components. Horizontal component is 5 cos 30, vertical component is 5 sin 30. Now, simplifying this rectangular loading into single point load. This is 4 kilonewton and this is 3 meters. So 4 into 3, 12. This loading will be acting at 1.5 meters from this point or from this point. 1.5 meters, or from this point B, it is 0.5 meters. Now, simplifying this triangular loading, 2 into 1, half 2 into 1, this loading will be acting at half 2 into 1. This loading, this single point load will act at 2/3 from apex or 1/3 from base. Base is E, this 2, and apex is 0. So it will act at 1/3 from this point or 2/3 from apex. From apex, 2/3 of 1 is 0.67 meters. Now, this is couple of magnitude 2 kilonewton meter. It is anti-clockwise. So, couple is having magnitude of moment of 2 kilonewton meter. This is roller support. This is hinged support. For roller support, there is only one vertical reaction VB, and for hinged support, there are two reactions HE and VE. Now, resolving forces horizontally and vertically. First, resolving forces horizontally and equating to 0, that is summation Fx equal to 0. This force He is directed towards positive x-axis. This force 5 cos 30, it is directed towards negative x-axis. So, plus He minus 5 cos 30. So, we get He value. Now, resolving forces vertically and equating to 0, that is summation Fy equal to 0. Vb plus Ve equal to Vb plus Ve minus 3 minus 12 minus 5 sin 30 minus 1 equal to 0. So, we get equation in Va and Ve, say it as equation 1. Now, taking moment of all forces about point A, point B, moment of 3 kilonewton force about point B will be, it passes through line of action of force like this. It will have perpendicular distance about point B of 1 meters, and it will rotate about point A like point B like this, anti-clockwise. So 3 into 1 anti-clockwise minus moment of VB about B will be 0 because it passes through point B. It will have 0 perpendicular distance about point B. Moment of 12 kilonewton about B will be 12 into 0.5. It passes through line of action of force like this. It will have perpendicular distance of 0.5 meters from point B. It will have magnitude of moment of 12 into 0.5. 12 into 0.5, and it rotates about point B clockwise like this. Moment of this couple of 2 kilonewton meter about point B or anywhere on the point, any point on the plane will be 2 kilonewton meter. Rotation is anti-clockwise, so minus 2 kilonewton meters. Moment of this 5 cos 30 about point B will be 0 because it passes through line of action of force like this and it passes through point B. So moment of 5 cos 30 about point B will be 0. Moment of this 5 sin 30 about point B will be, it passes through line of action of force like this. It will have perpendicular distance about point B of 4 meters and it rotates about point B clockwise and it will have magnitude of moment of 5 sin 30 into 4. 5 sin 30 into 4. Moment of this HE force about point B will be, it passes through line of action of force like this. It passes through point B. It will it will have 0 perpendicular distance about point B. So moment of HE about B will be 0. Moment of VE about B will be, it passes through line of action of force like this. It will have perpendicular distance of 6 meters from point B and it rotates about point B anti-clockwise and it will have moment of VE into 6 about point B. So it rotates anti-clockwise, so minus. Moment of this 1 kilonewton force about point B will be, it passes through line of action of force like this. It will have perpendicular distance about point B of 6.34 meters and it rotates about point B like this clockwise. So its magnitude of moment will be 1 into 6.34 clockwise, so plus. We have resolved forces horizontally and equated to 0. We got HE value. We have resolved forces vertically and equated to 0. We got equation in VA and VB and VE, and we have taken moment of all forces about point B and we got VE value, and so we have substituted VE value in this equation and we get VB value, and for here we got VE and HE. We have to calculate RE. We can get RE by square root of summation HE square plus summation VE square. We get RE value. Theta we get by tan inverse of VE by HE. So theta we get. So we got RE and theta.